Okay, now we are going to do some stuff with some polynomials. And this was, like I said, that first section was kind of like introduction to polynomials. We didn't do a lot of math. We did a little bit, not a lot. This is all going to be straight math, okay? Everything that we do on this section is basically examples, okay? Things that you should probably already know how to do, but we'll show you. So let's talk about things called like terms. We mentioned this in the last lesson. Like terms, that you can only add like terms. Okay, now I'm set. So let's talk about what are like terms. And we're going to talk about terms that are not like terms or unlike terms. So for instance, like terms, you can have a different number in front, but your variable and your exponents have to be exactly the same. Everybody hear me on that? All right, so the number out in front. Does anybody know what the word for that is in math? The number out in front that's like a 5x. What is the 5? It's got a certain name. It starts with a C. I'll give you a hint. It's not a constant. If it was just 5 sitting there by itself with no x, that would be a constant. But when it's 5x, anybody know? It's called the coefficient. Very good. Okay, it's called the coefficient. So if I have, like 3x squared and then 5x squared and 7x squared, these are all like terms. You're like, Mr. Hamrick, they're not the same. They're not like. That's got a 3, it's got a 5, it's got a 7. But the coefficients can be different, all right? It just means how many of these things that we have. This means we have 3x squareds, we got 5x squareds, and we have 7x squareds, okay? So it's like having 3 apples, 5 apples, 7 apples. They're all the same thing. They're all apples, right? The 3, the 5, and the 7 just says how many of these things that we have. So are the like terms the same? Do I have apples and oranges here? No. I've got apples and apples and apples, but they're not apples, they're x squareds, all right? So I've got 3x squared, 5x squared, 7x squared. These are all like terms. What if I had something like this? What if I had, we'll get a little bit more complicated. What if I had 5x squared, or x cubed y squared? I had 17x cubed y squared, and they throw some random big number in there. If I had 103x cubed y squared. Are these like terms? Absolutely. The 5, 17, 103, they can be different. That's fine. Just tells you how many of these things that we have. But look at my term. What is my term? My term is x cubed y squared. This is the same exact thing, isn't it? This is the same exact thing. So they're like terms. Everybody with me on this? All right. What if we had some unlike terms? Oops. Paper's going to blow away here. Here's an example of some unlike terms. So let's write that down. Unlike terms. So right now we're not really doing any math like I said we were. This is pretty much the only time we're just going to talk about stuff. Then we'll actually start doing some math here in a minute. Let's talk about some unlike terms. So watch. These are straight from the book. 8 x to the 7th y to the 9th. All right, let's take a look at this. Are these like terms? I got x and y's in all of them, right? Yeah, but I look at my variables though, or my exponents, I'm sorry. My exponents to those variables are different. So just an x and x to the 4th and an x to the 7th, they are not the same terms. They're completely different, even though they both have x's in it. Okay, they are unlike terms. So if your exponents are different, then you're going to have unlike terms. Everybody with me? The 4, the 12, and the 98, does that make any difference whether they're like terms or unlike terms? No, it doesn't make any difference. But right away, x to the 4th, x to the 7th, right away, those are unlike terms. If my y's were exactly the same, these 3 would still be unlike terms. Everybody got it? You can't add these. You can't do anything. So if I said add those up, what would you do? You can't do it. You would just write down what I've got right there, okay? That's all you would do. I kind of doubt they're going to do that, but every once in a while they'll do that, okay? They'll give you a whole bunch of stuff. They'll say, add it together. And you're like, wait a minute, I can't add them together because they're not like terms. So you just write it the way, that's all you could do. That would be your answer if I told you to add those together, all right? Everybody got me on that? All right. So what if, we talked about terms, let's talk about adding like terms. We said this earlier in the last lesson. Nico, you're the one that brought it up with the t squared and the t. All right, what did I say? We can only add what? Like terms. You can only add like terms. Like right here, they're not like terms. I couldn't add those together. All right, let's go super, super basic before we get into the real ones. What if I said 3x plus 7x? First of all, are they like terms? Look at them. Are they? Yeah, they are, because they both have exactly an x, right? This has 3 in front, that says a 7 in front, but this is x to the first, that's x to the first. Yes, they are like terms. So we can add like terms, and it's super easy to add like terms. A lot of students, though, get confused on this sometimes. They like to add the exponents as well, but you don't add the exponents. So what you do is you add, here, I even wrote this in my notes. You add the coefficients. I think coefficients has 2 F's. I was going to look it up. It looks weird, but I think it's 2 F's. Anyway, you add the coefficients and you keep the variable. I could say you keep the variable the same, but we just keep the variable, okay? Remember that little phrase right there. You add the coefficients and you keep the variable. So which ones are my coefficients here? 3 and the 7. So I add them up. What do I get? 10. And then you just keep the variable. What's the variable? And that's it. That's all you got to do. Okay, you don't do anything with the exponents. You don't make it x squared or anything like that. All right, you just keep the variables exactly the way they were. All right, and you just add the coefficients. So that wasn't even an example. That was so pre-example. All right, so here is example 1. They write it like this. They give you 2 polynomials. They put the word and in front of it, and they say add them together. I think that's weird. I'm just going to put the plus in between them instead of saying and. Is that all right?
Please report to the main office. Karen Bradford, report to the main
So
office.
3x squared. Actually, yeah, that's fine. I can do it like this. 3x squared plus 2x squared minus 2x Nope. Sorry. You didn't write that much, did you? All right, let's write it like this. I was looking a step ahead. I want to write it like this because there's this one little step that I want to make sure you understand. All right, so we're going to add it. They put the word and right here, but I'm going to put a plus sign. All right, and then 2x squared plus 4x. Because all I would do, when they put the and there, all I would do is just rewrite this anyway and stick the plus in there. So why bother? So now here we go. We're going to add this stuff together. And that's what they would tell you. They would say add. Add the polynomials. That's what we're doing today. So first of all, you got to go through and see which ones are the like terms. Now remember what we talked about yesterday. Remember we talked about ascending order and descending order? What is the way that I said that's the one that we use almost all the time? What order do we use almost all the time? Descending order. So I'm going to put it in descending order. So that means which one is the highest order? Which one's got the highest power? The x squareds, right? So I'm going to do those first. Now, do you have to get it right? No, you don't have to. You could put it in any order, to tell you the truth. Okay, but just to be consistent with the book, with every other mathematician that's ever lived doing these things, I would be very close to saying we always put them in descending order. Okay, maybe there's a couple weird situations where you don't, but for the most part, I would say put it in descending order. So let's do the highest powers first. So I've got the 3x squared. What other one is a like term with that? The 2x squared. So I just add those together. What do I get? 5x squared. That's right. Okay? Everybody with me on that? Yeah, easy. This is Algebra 1 stuff, tell you the truth. Do you remember doing this in Algebra 1? What's the next highest power? And here's what I like to do. You don't really need to on this problem, but if you have like a whole bunch of stuff here and you're adding up a bunch of like terms, I like to cross out the ones that I've already added up. Does that help a little bit? It helps me. All right. So what's my next one? Let's do the x's. Yep, it's negative 2x plus 4x. Or you could say, like Faith did, 4x minus 2x. What is that? Plus 2x. Oops. All right, and I get rid of that. What else is left? Yeah, what is it called? You guys already said it earlier. What's it called when a number is just sitting there by itself? with no variable. It's called a constant. It's called a constant, okay? So let's add the constants together. So positive 4, negative 3, that's easy. That's what? Plus 1. Can you simplify that any further? Can you combine the 5 and the 2 together? No, because they're not like terms. Boom, there you go. Simple. This should just be review for you. Is that correct? Yeah, I think so. Let's do one more, at least. We'll see. I got 10 minutes. I'm moving pretty quick today. So example 2. Let's add these together. All right, here we go. 5. Do what? Like right there? You good? Okay. All right, let's go, let's see, 5x cubed y squared. Let's go plus 4x squared y cubed. Minus 2x cubed y squared plus 5x squared y cubed. At first glance, these look complicated, right? Because you got all these exponents, all these letters and stuff like that. But really, once you break it down, it's actually pretty simple. It's like when you were in, I don't know, what grade? What grade do you learn to add and subtract? Like first grade or something like that? Okay, third grade, not till third. So anyway, it's almost as easy as that. You just have to find out which ones are the same term. So look at the first one. I got an x cubed y squared. I don't care about the 5. Okay, I got x cubed y squared. Do I have any other things in here that are exactly x cubed y squared? Yeah, this one right here. So those are the ones that I'm going to add together. So this one and this one. Now look, that has an x and that has a y. It's got a cubed and it's got a squared, just like that. But are they like terms? No, because the x has to be cubed and the y has to be squared. These are the only two that do that. You with me on that? All right, so let's add them up. 5 minus 2 is what? 3. And then you just keep the term. What's the term? X cubed, y squared. Boom, boom. We're done with those. Are the other two, are they like terms? They are, because it's x squared, y cubed. X squared, y cubed. They are like terms. I just add them up. Super easy. Add the coefficients, 4 and 5, 9, and you just keep the term. And the term is x squared, y cubed. And that's it. That's all you can do to that. Basic, right? Yeah. They do another thing. I'll tell you what. I'm just going to show you one example. I'm not going to. They do some problems like this in the book. So let's do it. I'll do the first example. This is I'm redoing example 1. Remember example 1? Right there, that 3x squared minus 2x plus 4. But they do it vertically. Up and down. That's right. That's vertical. So they're going to say add. And here's how they write it. 3x squared minus 2x plus 4. And then, again, this is the same exact problem that we did on example 1, except we're doing it vertically this time instead of horizontally. It's not example 3 yet. This is just another way to do example 1. It's to do it vertically. All right, so vertically. There are times, I definitely remember times where, maybe not for addition, but for other things, it might have been a little easier to add vertically. Some people like doing it vertically. Some people like adding horizontally. For the most part, though, when you see math books, almost all the time, except for very few exceptions, you're going to add things horizontally. All right, but I'll throw this in here because they put it in here. And in some of the problems in the homework that you have to do, they give you a few problems where you have to add these vertically. But it's actually kind of nice. Some of you might like this better because everything lines up, right? You don't have to like come over here and then go way down here and pick one, right, that's the same term. All the terms are lined up. So this could be a little easier for a lot of you guys.
Was it already in the book, like lined up with each other?
Sometimes in the book, some problems in the book, they will line them up like this, okay? All right, so you'll see that this is actually kind of easy. See, all my like terms are lined up, aren't they? So I just add up and down. So what is that? 3 and 2. That's just 5x squared. Add those up. plus 2x. Add those up, plus 1. All right? You could see the benefit of that, couldn't you? All right? If they're lined up, right? If all the like terms are lined up together, yeah, you could definitely see the benefit of adding them vertically. But most of the time, when you have to add like terms, you're not going to be adding them vertically, all right? But a few times in the book, they will have you do that. I just thought I'd throw that out there just so you could see. So we did addition of polynomials. Obviously, what do you think is next? Subtraction. So it's basically the same exact thing. So this is example 3. They give you a bunch of them. I don't know if we'll do all of these, but I think we'll just do one easy one, and then we'll do some other ones that are a little bit tougher. So if I have 8x squared minus 3x squared, really, this isn't really any different than addition. The rules are exactly the same, except you don't just add the 8 and the 3. What do you do to the 8 and the 3? You subtract them. It's 8 minus 3, which is 5. You keep the term. And so really, the spirit of the problem is really no different than what we've done before. Now, let's do example 4. There is another one for example 3. There's actually 2 more for example 3, but that was good enough. All right, let's do example 4, and we probably will only be able to do the first one. So let's write it down. So it's 8x cubed y plus 2x squared y. They put that in parentheses. Then they put a minus, and they put another parentheses. 2x cubed y minus 3x squared y. Now, I kind of doubt that you guys look at the book and look at the examples and try to do it the way they do it. So I do it a little different. I think the way they do it, I think is kind of confusing, to tell you the truth. So here's how I would show you how to do this. Right here, the parentheses is really not needed in that first set, that first polynomial, all right? But it's definitely needed in this one because I got this subtraction. You've done this since Algebra 1, right? You've seen this, haven't you? What do we call it? What property do we give that? Distributive property, right? This is the distributive property. We take that negative and we distribute it through. So let's write everything. I'll try to do this quickly. We only got like a minute left. Now, what's this going to be? It's not going to be plus. It's going to be what? Minus 2x cubed without the parentheses. What's this going to be, though? It's going to be positive because it's negative times a negative. Negative times a negative is positive, and then we write 3x squared y. That's the part that some people get mixed up on. Usually they get the first part right because they see that minus. But then a lot of people will look at that minus and say, oh, it's just minus. It's not. You're distributing that negative through both of those. Now, let's subtract like terms. Which ones are like terms? The 8 and the what? And the negative 2, right, because it's x cubed y, x cubed y. 8 minus 2 is 6, x cubed y. I'm done with that one, done with that one. Are these like terms? Yep. X squared y, add them up. Even though it says subtraction, I mean, this part you are adding, so it's 2 and 3 is 5, and it's x squared y. You can't do anything else with those. They are not like terms. Even though they have a x and a y in it, they're not the same, so you can't do any more than that. You keep it like that, circle it, and that is your answer. There is a part B to that. It's a little bit longer, but it's basically the same exact thing. If I had 5 minutes, I'd do another example, but I don't, so I won't. All right? So just do that homework. Do the 5-1 homework. You don't have to do any homework on 5-2, okay? I'll do 1 or 2 more examples tomorrow, then I'll assign that tomorrow. Everybody good?